Okay. I know last time I went not too fast, I don't think, but a little quicker than I wanted to. At least for the other class I did. So I figured it'd be good for this class, for both classes actually, if I did some more examples from this, what we're doing, from chapter 2, section 2. So let me do that. Okay. So last time, if you remember, what we saw was the graph of an equation in two variables. You know, what we saw equations in two variables, you remember? And we also considered their solutions, which really was ordered pairs of real numbers. Okay? Ordered pairs of real numbers were solutions to equations in two variables. You know, it was a step up from 1.1, if I remember correctly, where we had equations in one variable and only numbers were solutions. Okay. And we also related this to the graph of an equation, namely the graph of an equation in two variables, you know, in two variables, x and y is what I really mean here. It's just the plot of all the solutions, all the ordered pairs that are solutions to the equation. That's just what it is by definition. So for example, I told you the parabola is by definition, the graph of this equation. You have y equals a polynomial of degree 2, where a, b, and c are numbers, but a is not 0. The graph of that, no matter what a, b, and c are, is called a parabola. It's really going to be some variation of the graph of y equals x squared. You can easily graph that using Desmos or GeoGebra. Desmos is actually not, it's pretty easy to graph in. In fact, I think I've said this before, but Desmos you can actually download as an app on your phone, you know, your smartphone that is. You don't have to, but you can though. It's also a web page you can get to easily. Okay. We also saw the x and y intercepts of these equations in x and y. Remember, to get the x-intercept, you set y equal to 0 and solve for x. For the y-intercept, you set x equal to 0 and solve for y. In other words, what you're doing is you're setting the other variable equal to 0. That's really what you're doing and solving the equation. I did just email these notes, just letting you know, as a PDF. Okay. And we also saw circles, and the circle with this center, you know, this is some point in the Cartesian plane. R is a positive number, it's the radius. Well, yeah, R is a positive number. And the circle with center HK and radius R is the graph of this equation. It's the graph of this equation, okay? And that's actually if you think about the distance formula and what a circle is, it's really no coincidence. I mean, essentially, remember the circle with this center and this radius, it's all points in the Cartesian plane that are r units from this point. And then if you went to the distance formula, you would, and squaring it actually, because there's a square root in the distance formula, you would end up with this equation. Okay, good. And also, this was a graph I showed you last time, the function y equals 1 over x. Well, not the function, excuse me, the equation I meant to say. Functions we'll get to later. Not today, though. But this is what the graph looks like. You know, it doesn't hurt to know this graph. I mean, yes, you have graphing technology with smartphones and computers, but it still would be beneficial to know what the graph of this looks like, what the graph of this equation looks like. What's interesting about it is it never touches the x or the y-axis. In other words, it has no x-intercept nor a y-intercept. I mean, it's really not hard to come up with a graph where that happens. I mean, you could easily draw a circle, for instance, whose center and radius are such that the circle never intersects the x or y axis. Okay. All right. So that's one example. Here's another one I did not show you last time. I drew this in Desmos. Okay. We have y equals the square root of x. This is the y equals the square root equation, I guess, so to say. But this is what the graph of this looks like. Hopefully you can see it. It's not too hard to see. Okay. It does keep on going, meaning this graph keeps on going, never stopping. So it's another graph that's good to know. Okay. I mean, odds are I'm not going to ask you to just graph it on an exam or quiz because, you have the graphing technology at your disposal. And to me, it would not be really too beneficial for that. So to do that, I mean. So anyway, that's what we have here, square root. Okay. All right. So this is just another example I wanted to present. So again, here we're graphing this equation. I mean, actually later on, I think in chapter 3, if I remember correctly, 3.1, we're going to actually graph this in a more rigorous way. But for now, all we can do is just list a bunch of x values as I'm doing here, then calculate, as you can see, calculate the corresponding y values and plot the corresponding points. It's not really efficient, so to say, but, again, it's better than nothing for now, at least. So anyway, so the x values I chose kind of randomly, I guess. Well, maybe not randomly, but I chose them. On a test or quiz, I would give you the x values, and you would have to fill out the rest of the table, so to say. Okay. So for instance, if x is -2, right? You replace x by -2 into the equation, as you can see. We get our y value to be 6. I'm pretty confident that that calculation is correct. Okay, so we get 6. And we have -2, 6. So that's a point on the graph. The graph I drew with Desmos, actually, the graph of this equation. So this is right. I mean, normally the graph you would do at the end, but I presented the graph here anyway. So -1, right? When x is -1, we calculate the corresponding y value as well, as you can see. Right, so when we replace x by -1 by direct calculation, we get 1. So this point's on the graph as well. -1, 1. I think it's over here. It might be kind of hard to see, but it's over here about. And basically, you keep on doing this. And then we get 0, -2, 1, -3, and 2. Let me see, -2 as well. I know there's no comma here, but we get 2, -2 as well. And then you could sketch it by hand. I sketched it with Desmos, but hopefully you still get the idea. I mean, normally in class, I would have you sketch it by hand, but, we're doing this virtually, though. Notice again, this is what the graph looks like. This is a parabola. Okay, again, we have y equals a polynomial of degree 2. So we have a parabola. Okay. Notice that we have the y-intercept. Essentially, I just let x be 0, right? And I got -2. So -2 is the y-intercept. The x-intercepts, I don't know what they are. That would take more work to find, but here's one over here, and here's another one. So we have those. Okay, that's good. Now, this is an example I want everyone to try, to find the x-intercepts and y-intercepts of the graph of this. I'll wait like 2 or 3 minutes. But again, you're just using what I did last time and really what I just said. For the x-intercepts, you set y to be 0. For the y-intercept, you set x to be 0. Okay, so I want everyone to try that out now, actually. Take about 2 or 3 minutes. Okay, so let me just pause this. Okay, so we're going to do this intercept now. All right. Okay, so again, for the x-intercept, right, as I said before, you're going to want to set y. You set the other variable equal to 0. So we're going to set y to be 0, and we're going to solve for x. Okay, that's what we're doing here. Okay. So in this case, I set y to be 0, right? The 2 times y part is gone. We have 9 times x equals 5, as you can see.
The
So
PowerPoint isn't up on the screen.
What
Yeah,
happened?
are you sure you're still sharing your screen?
By what? Uh-oh.
You're
Sorry.
not sharing your screen anymore. We can't see the slides.
Oh, I'm sorry. Let me get it. How's that?